Hi everyone, thanks for being here. I hope everyone enjoyed the party yesterday. Yes, good to hear. So today's talk will be about GraphQL for microservices, and I'll also be explaining a bit what GraphQL is, in case nobody knows, and of course microservices. So who's this for? I actually found this meme about companies going to microservices while they actually didn't need microservices. Is anyone using microservices here? Some people are. And who actually discussed using microservices in their company? Some people did. But I often hear from companies as saying either the architect or maybe some team lead or maybe someone else in the company is suggesting, should we do microservices? And microservices are great because you get a lot of advantages, but also if you're 4 developers in the team, you also get probably more disadvantages. So that's why I like this meme. You often see companies going to microservices and then taking it the wrong way. They make the microservices too big, or they make sure, or there is no clear pattern between all the microservices, meaning they got microservices, but in the end, it's just like 5 small monoliths. So when you're trying to introduce microservices in your company, make sure to think about this before actually converting them. If you already have them, that's great, because they can give you a huge amount of value. A little bit about myself. So my name is Roy. You can find me on Twitter using @GetHackTeam. I'm from Amsterdam, the Netherlands. And besides that, I work for a company called StepZen, which is a GraphQL as a service company. I also give trainings and workshops through my own company. And I recently released a new version of my book, React Project. So if you want to read this book, make sure to talk to me after this talk, because I have a couple to give away. I didn't bring them with me because my suitcase is already full, but I will make sure to ship them to you. And also you can find some of my talks on YouTube. If you want to know more about GraphQL after this talk, or want to watch any of my React or TypeScript talks, make sure to find my name there. But the first question, what do you already know about GraphQL? Are people familiar with GraphQL? I am. More people are, that's good to see. It's good to see. So let's quickly go through it then. And also why GraphQL is perfect for microservices. So GraphQL is a query language for APIs. I often hear people asking, what is GraphQL? Is it a framework? Is it a library? What is it? It actually is a query language for APIs, meaning it's not a framework, it's not really a library, it's a specification. And this specification was created almost 10 years ago, but for the last 6 years it has been open sourced by Facebook. And after Facebook open sourced it, it actually became part of the GraphQL Foundation. So if you want to introduce GraphQL in your company and people are afraid it might be a Facebook product, it isn't. It's now part of the GraphQL Foundation. So feel free to use it in your company without any constraint of introducing any big tech languages that maybe some of your company are opposed to. And what does it look like? It looks like this. On the left side you can see what we call a GraphQL query, which is one of 3 operations in GraphQL, and with a query you can request data. And the query is always read-only. So if you would be using REST nowadays or any other HTTP framework or HTTP specification, a query is often a GET request. So if you have a REST API and you do a GET request to get information from your API, it is called a query in GraphQL. And in here you can see you define fields on the left side, fields you want to request, the fields you want to see in your application, and then on the right side you can see the response, which is always JSON, which is also important to understand. GraphQL is tied to JSON, so whenever you send a request, you can expect to get JSON in return. And also you can ask the fields you want. As you can see on the left side, you can see we're requesting information from a GitHub user using a parameter GitHub teacher, and then we request some fields like a bio and also some direct correlations or relationships this user has, like its followers on GitHub. And then on the right side you can see the JSON response, and it follows the same shape. You can see the same fields are in there. So as a front-end developer or even as a back-end developer, it's really convenient because you always know if I request this data, I will get the same data back. And you no longer have to open the REST API in Postman or in a different browser tab, scroll through all the fields and figure out what you want. Instead, GraphQL will really help you interactively to find the data you need. And it also offers a single endpoint for multiple resources. So I don't know about you, but I've worked in companies that have REST APIs with 20, 30 or 40 or even more REST API endpoints, and it's really hard to keep track of where your data is and what data you need to actually fill your UI. With GraphQL you have a single endpoint for all your data sources. So assuming you maybe work on an e-commerce project, I've worked in e-commerce for years, and often API endpoints are splitted, so you will have an API endpoint to get your product information, like the price or the title of the product. Then probably you have some other endpoints to get reviews or get any other user-generated content. And then maybe you have a third or a fourth API call to get breadcrumbs or maybe any other things on the page. So with REST APIs, you often need to do multiple REST API requests. With GraphQL, you can actually get relationships for your data within the same query. So you don't have to send different queries to get different sets of data. Instead, you just send one query. And if you look here, you can see I'm getting some information from Twitter. And in Twitter, if you look at the REST API they have, actually they split the data between tweets, retweets, and then authors as well, so Twitter users. And as you can see with the GraphQL API of Twitter, you can actually get data from the author within the same query. So you don't need to send two different requests. Instead, if you send just one and you get all your data at once. And then the most important part for me, it's based on the type system. Are people here using TypeScript? Nice, almost everyone, so that's good to see. It's based on the type system, and if you look at a REST API, you typically don't have a type system. You sometimes have an open API or a Swagger specification, but I think in the end people don't really make these things up to date unless they're auto-generated. So GraphQL is a type system, meaning if you look at the queries, and if you look through the queries in an interactive playground, so GraphQL often has an interactive playground that people use for documentation. So instead of having static documentation, as you see for REST APIs, that is either generated with OpenAPI or maybe people keep track of it in a markdown file, because I've actually seen this happening, or even Google Docs, which is okay to document your APIs, but it's not actual up-to-date interactive documentation. With GraphQL, you can find a schema, and the schema is at the basis of every GraphQL API. And through the schema, you can define which queries you can send, or other operations, of course. But you can also find the types of all the data that you get as response. So if you send a query, in this example to get tweets again, and also the order of the tweets, when you look at the schema, you can already find the types of all these fields. And there are actually libraries. If you're using TypeScript in your front end and you want to build a GraphQL API for your backend, you can actually use libraries to generate the TypeScript types for you. So it also helps you if you're building full-stack applications that GraphQL is a type system, because it will make your front-end development way easier. And also GraphQL is all about graphs. And this is where we get back to the microservices part, because graphs really help you to understand your data, and it also helps you to extend your data and share data with multiple teams. And this is important for microservices, as microservices are domain-based. And a graph also is domain-based. So you can imagine if you have a very big company and you have GraphQL for all your microservices, you can imagine all your domain-based microservices will have their own graph, which will define all the data that is available for these domains or these services. So if you look at this example, it is a client interacting with 3 different microservices without any API gateway in between. And typically, if you then want to get the data, you need to send requests to all these different microservices. And they will get the data for you, they will return it to your front end, and then your front end can display it. But all these services should have its own domain. And that takes me back to my very first point. If you want to do microservices, make sure you actually make microservices and not just multiple small monoliths. Because every service should have its own domain. And this can mean if you have a large company, that maybe every team working on a part of your product has its own domain, or maybe if you're just one team, it can also mean that every developer has its own domain which he or she is responsible for. And if we put words on this, you could say that you could have microservices that is a authentication service, then probably you have a microservice that goes about your users. Most products have users, I hope at least. And then if you're building a blog or whatever, you can have a post microservices. And here the distinction is important, because if you look at the top one, it is authentication, but the other services don't have authentication, meaning you would need to have this microservices as a vital service within all your services for the other services to be able to authenticate. And each microservice can then have its own graph, as I said. So per domain or per service, you would have a graph. And this will, of course, also work if you have a monolith. You could maybe say this part of my monolith has its own graph, while a different part also has its different graph. Yesterday, I spoke to some people here who are using Nest.js, an example. And also there you have something called controllers, which will help you define a domain. And for GraphQL, it's the same. You could basically create a graph for all of these different controllers or domains within your monolith as well. But if you want to GraphQLize this microservices setup, you typically need to create a GraphQL schema for each of these services. So your authentication service will have a GraphQL schema, your user service will have one, and then your post service will have one. And all these different teams or different services are responsible for the data that is in there. And then with GraphQL, you can bring them together in one schema, which is a really nice thing. Because with GraphQL and thinking of graphs, it's important to understand that you can make different relations between those graphs. So suppose you go back to your authentication service, or your user service, or your post service. Let's suppose you want to show the author of a post, which is a user, or maybe you want to get your authentication token first before you actually get the user data. For this, you need to make combinations between the two graphs, and for this, GraphQL is really convenient. And for this, I often say you need to create a GraphQL data layer or a GraphQL API gateway. There are multiple terms for this. If you already have microservices, you are maybe using a API gateway already. Maybe if you're more in the infrastructure side, you're maybe building a service mesh, which is also possible, of course. With GraphQL, you can combine schemas. So suppose you would have these different graphs, you can combine them using GraphQL. And there are multiple ways to do so, as I will show you. But important here is to understand that all the things I can show you, those are all directly correlated to GraphQL. So no matter which implementation you choose, each of these implementations will help you merge data or bring data together from different graphs. And then one thing I also wanted to state, so GraphQL is often seen as a replacement for REST, which is something I hear a lot also on Twitter, or if you all talk with people, they're saying we're using REST API, so we cannot use GraphQL. Or we're using GraphQL, so we cannot use REST. I think the two can often easily coexist because they serve a different purpose. I see GraphQL mostly as an API language for teams that build experiences or user interactions, while REST API might be very convenient for integrations with maybe third parties or maybe with other services that are outside of your company. So the two can easily coexist. And I think if you go back to this meme, you can also say developers can use both REST and GraphQL at the same time. And merging GraphQL schemas, as I said, can be done in different ways. There are multiple terms for it. I think GraphQL schema, well, the idea of bringing schemas together is actually quite old, ever since the beginning of GraphQL. And for this, you might have heard about schema stitching. So schema stitching was the first way to bring GraphQL data together. It was created by Apollo when they started building Apollo server and Apollo client. And with schema stitching, the most important thing to understand is you're writing data to writing code to bring schemas together. So you're stitching schemas by writing code. And if you look at this example, you can see at the top, you would define the schemas you want to stitch. So let's say you have a schema for your users and a schema for your posts. You need to define where you want to stitch them. And then you need to define you want to extend types in any of those graphs by using types of the other graph. So first you define the schemas you want to stitch, then you define which data you want to stitch, and then you need to write custom resolvers to bring this data together, which is a really great way if you're building your API data layer by hand. So I've seen multiple setups here. Some companies actually want to build an API gateway using code, so they want to write an extra GraphQL server that brings together all these different Node.js microservices and stitch the data together there. So this is really great if you have one programming language for your entire company, because then everyone knows how to make changes to this gateway. But if you have multiple languages within your company, it's actually harder to have one gateway that serves all the different teams or domains. So for this, federation might be an answer. So Apollo actually also came up with federation because they figured out at some point that the issue I just said, Companies want every developer to be able to make changes in their gateway, and for this you need a more declarative approach. And with declarative, I mean you can use the GraphQL schema to bring data together, instead of having to write a server that brings this data together. And what Apollo does with federation, they will call it GraphQL federation, and also a GraphQL gateway is the sort of the layer that your clients will interact with, that stitches together or merges together all the underlying data from different services. For this you actually need to create something they call a supergraph. So let's suppose every microservice is a graph, then you will call these graphs subgraphs. And then at the top you will create a supergraph which brings together all these different subgraphs and lets you query the data from each of these different subgraphs, but also, more importantly, bring data together from these different services. So suppose you have your user servers and your product servers or your posts, and you want to combine data, you will combine this data in the supergraph. And then you can just use a new GraphQL server at which you will bring this supergraph available to your users. And this is all based on Node.js, while under the hood it's actually using Rust to make sure all the data is being connected as fast as possible. I think they actually had some issues as well. So previously the gateway was built using Node.js, and I think they got stuck at some point in which they could only horizontally scale, which means you would need a lot of different servers in order to get this data out there. And now with Rust they have a better experience. And there was a workshop about Rust actually on Thursday. And if you're already a JavaScript developer, especially with TypeScript knowledge, Rust can be a nice language to learn. But luckily this abstraction layer from Apollo Gateway is just exposing Node.js. So for most of us it should be easy to make changes here. And this might feel overwhelming because I've talked about microservices, subgraphs, bringing graphs together in a supergraph, or schema stitching. So it can be a bit overwhelming. So let's have a look at a different example, which is a tiny bit easier because this way you don't need to build your own GraphQL server anymore. And we go back to the original setup. We have 3 different services. We want to bring them together because from your client you're now still sending, I don't know, like 6 requests to get a token, actually to request the token, to get the token back, use that token to get a user, and then use that same token to also get posts. Because in the end you want to show some correlation between users and posts. As I said, maybe there's an author of a post, or maybe you have a user profile page at which you want to display all the different posts that the user has written. Typically you would send a lot of different requests if everything is split in microservices. So I actually created a demo for this, but before I show the demo, let's walk through what I will do. So I actually built Node.js microservices, 3 of those, the ones you already saw for authentication, user, and post. And what you will need to do if you want to use GraphQL to stitch them together, you would need to create a schema for every microservice. Unless they of course also support GraphQL. So let's say you maybe have 2 microservices using REST, and then you have another one that uses GraphQL. The only thing you need to do is create a schema for each of those REST microservices, and then you should be able to bring them together, either using schema stitching, Apollo federation, or the example I will show you. And for this I will use StepZen, which is a product to make declarative GraphQL APIs using either a CLI or a GraphQL schema design language for basically any data source. And the schema that it will create, you can still stitch it with schema stitching or use federation, or you can even use StepZen directly to bring schemas together. Or you can also use the CLI if that's something you would like. I can show it you later. Or you can write GraphQL schema design language. And this is something I really like because the GraphQL specification was written in a way that everyone can create custom directives. So you can use the GraphQL specification, the GraphQL runtime, and also the GraphQL types that you can see here. And then you can just write your custom directives to make any change here that you would like. So what we've done is we've taken custom directives, which you can see with the @ sign, so at rest, to actually create resolvers within your SDL instead of having to write them using Node.js yourself. And for this, as I said, I will be creating a graph for every microservice, unless they already support GraphQL, of course. And then we can merge the schemas together and we can deploy them. But let me go to my example. I actually tried to keep this simple, so what I've done, I've actually created a JSON file that I will use for authentication and to get my data, and then I used a service called my JSON server, which also has a JSON server library, which lets you create mock REST APIs. As I've done here, I've created a basic authentication service that is doing nothing but just checking if my credentials are okay, so I will get a bearer token for OAuth. And then any of these other services, the only thing they do is just exposing the JSON file. So it's mock Node.js services, but it's a really nice way to start testing. And then I can just run npm start to start up my microservices. And I've also used NodeMon, so if I will make any changes to any of these services, it will automatically restart. And also, if you see here, it is creating local tunnel URLs for every service. And this is because if I want to use StepSen or I want to use Federation in general, it is often advised to have an API endpoint you will expose it on instead of localhost, because nobody knows where your localhost lives. So if I would be going to this local tunnel URL for my post services, let me see where my Chrome is. It is here. And this is a friendly reminder of local tunnel that you actually shouldn't be using this local tunnel in production. But luckily we're here sitting in a conference room and not in a production area. So what it does, it exposes my local host through this endpoint. And as it's no longer on localhost, I can also have HTTPS requests, and it's just a bit safer. And in here I've created a API/posts endpoint. Posts, yes. So what this API is doing is just exposing the data I have in my JSON file. And then of course I can also use pet parameters to get the first post, and I believe I can also use query parameters, like to get the author. I see I have author ID 1. So this will get multiple posts. So this is a very basic REST API for posts, which could be a microservice of course, because it could be pulling data out of your database, or maybe getting data out of your CRM. It can be basically anything. And we have some things we can work with, like a query parameter or a pod parameter. And I've set up a similar thing for users and a similar thing for authentication. And then if we need to GraphQLize this service, you can either build a GraphQL API yourself, so you could use Apollo server and use resolvers to get data for every API endpoint. Or as I said, we can also use StepSen to do this for us. For this I would be going back to VS Code. And I could go into my post services, so I split my services up in different directories. If you're actually using microservices, you maybe have them all in one monorepo, or maybe you have different repos per service. It really depends on how your company is set up. But if I would go to my post services, an example here, I could run a command to actually import my REST API endpoints into a GraphQL schema. For this I could run import curl, and then the curl will be my actual request that I want to send. And of course I can do multiple things, like making the naming a bit nicer. I could say I want to name my query posts, and maybe I also want my return type to have a nice name as well. Maybe I just want to name it post. So what this will do, it will send a request to your API endpoint. As you can see on the right side, there are some things moving around. It will take the response of my REST API endpoint and turn it into a GraphQL schema. And then this schema is something I can deploy to the cloud and then use as GraphQL. And later on, of course, merge together with any of the other microservices I made into GraphQL. As you can see, it created a type based on the REST response from my API. And it also created a query, which I can use, which is just my endpoint. And of course, I can do more things here. So let's say I want to get the first post, and then I need to not forget that my server has actually redeployed this REST API endpoint, as I've created a new file here. So let's copy paste this as well. So here I can use the pod parameters, but also the query parameters. to get the data for me in a better way. And maybe I actually want to use the author because what I want to do with my stitched GraphQL schemas, I want to combine one microservice with the other. So I'm now creating a GraphQL schema for my post microservice, and later on I could do the same for users and I bring data together. But for this, I will need to have a query to filter my post per user so I can combine this data together. Because if you would be working from a front end, you probably are using the same request to get data from for all the posts for that user. So in here I can do author is 1. Then I need to give a nice name because I'm getting posts by author in example. Just to make sure that I don't create the same query twice, which is something you don't want to do. And this creates a new schema with the pet parameter, or actually the query parameter, just based on my REST API endpoint. So this is a very convenient way to build a GraphQL schema for your microservices. But as I said, of course, you can also create your own GraphQL server by using Apollo server or Mercurius, which is a really nice GraphQL library by Nearform. So it really depends also how your company is structured. Something I often see is companies want to make these kind of structures, but they don't want to build the GraphQL layer themselves because they're focused on building REST. So this is one way to do it. I'm not going to turn all these different microservices into GraphQL, as I've already done this myself. So here you can see I've created a request to get posts, I've created one to get posts by user, and I've done the same for authors, for users. I also created some queries to get user information. And for this, to get this started, and I can show you how to bring data together, I actually need to take my local tunnel URLs and place them in a configuration file. So this is my authentication service, this is my user service, and then this is my post service. So this will feed these endpoints to my GraphQL schema. So I will be able to run steps and start, go back to my main directory. So this will start a GraphQL server based on all my different microservices. It will take the schemas I've created, either myself or automatically using something like StepsIn, and then it gives me a URL to where I can find the GraphQL schema, which is over here. And in here I can query all my microservices using GraphQL. So if we would go back, the first thing you always need to do is get an authentication token. Let me actually type this out again. So if we want to work with microservices, as in the setup I've shown you before, we first need to get an authentication token, and then we can use that token to get data from the other microservices. So in here, the nice thing with GraphQL is it will also give you auto-completion. And this works with every GraphQL server, as this is a GraphQL playground, which is somewhat of an IDE to work with GraphQL data. And it will give you some auto-completion, so I would be writing token. I can also figure out what is in there, like this. But I can also use this handy tab to find all my different queries. So these are all the queries I have. In example, the one to get a token. I can just press the response type and I'll figure out what data is in there. And here I can get an access token, which is sending a request to my REST API service. I can take this token, and then of course I could feed this token to my other query, which is getting post information, and then get this data using this this query. Okay, so this is very straightforward, of course, but the thing I wanted to do is actually merge these schemas together, because that's the thing you really want. You want to make combinations between your microservices instead of having to use different queries within GraphQL. So for this, you could use schema stitching, you could use federation. I've created something with StepSim for this, which is another custom directive called sequence. And with sequence, you can use queries in sequence, meaning you don't need to write custom code to do this, you don't need to link resolvers or link types. The only thing you need to do is use this custom directive and say, I first want to get my query with the token, and then I want to use the output, so the response of this query, to get my post data. And then it will take the output of token and use it as query parameters for posts. So if you look at these two queries, this is something I can automate by using one of the queries I've created that combines this data. So I can get post information, and then I can get the same fields as we have here. Just comment this out. And now it will still get my posts, but it will first get my token, and then it will use the token that was generated by my REST API and use it as input for getting the posts. And then, as I said before, we're using GraphQL, so you can also take out fields whenever you want. So even if your REST API is supplying all the data to your GraphQL API, in there you can define what data is returned using GraphQL spec. And there you can do cool things like caching, so you get the request once, and you don't need to be afraid that whenever you send the same request within a time frame that you would define, that it will get a second request to your REST API. Instead, you can use caching. So this is one nice way to combine data, but there are different ways as well. And there are more custom directives you can use, or even if you build your own GraphQL API, you can also make use of this way of combining data. Because something you could do, if I would be going to this file, is either use bigger sequences to collect data from different sources, or even combine data on a different level. So you could also say, if this is my user data, I can also get my post data here using what we call steps and like a materializer, and in here you can use a query to get data as well. So here you could say get, let me see what I called it, get post by user. Going here, you could say use this query, take the argument with post by user should be taking the query parameter user ID. Like this, and then you can see I want to use the field ID from user as well. And I link data like this. So there are multiple ways to bring data together when using GraphQL. And either if you federate with StepSen or federate with Apollo or use schema stitching to build your own GraphQL schema stitching layer, the setup is everywhere the same. You need to think in graphs. You need to think, I have a microservice for users, I have a microservice for posts. How can I bring this data together, and how do I want to bring it together? And it's the same when you design a database or when you design your REST API. You should think about the data you want. With GraphQL, the convenience is that you can easier make changes afterwards. So in the end, if it turns out your teams are using your data differently, as a backend developer, you don't need to set up your REST API endpoints differently. Instead, users can take different data fields from the GraphQL API and use them any way they want within their code. So what I've showed you is how to merge data using GraphQL with schema design language, using the custom directives, and then using StepSen you can also deploy them serverless without having to write any pipelines. But of course, what you can also do if you write your GraphQL server using any Node.js framework, you can also deploy them on an edge function or any other way you want to deploy them within your own existing setup, of course. For this, I wanted to show one more thing in the demo as well. So what I've done here, I've created all these different microservices, and the nice thing here actually is that the JSON server library I created, something I really use a lot for mocking, especially if you're building new tools, is making sure that you will expose. You can put this data in a GitHub repository. So let's say you have a public GitHub repository. You can just post this db.json file there, and then it will automatically create an API for you that you can use everywhere. So this is something I often use when building new mock services. And then one final thing about GraphQL here is that if you would be creating a schema for each of these services, then the important thing to understand is that GraphQL is not REST. So if you want to correlate all your REST API endpoints directly to a field in your schema, make sure to think about how these things will add up later. So if your REST API endpoint to get different fields for different schemas, make sure to structure the data in a way that you can easily extend it later on. But this will actually make sense if you try out the example. I think I put it on GitHub, so let me take this link for you. And then find it. Yeah, so this is the GitHub repository you can find it on. And then the only thing you need to do here is, after cloning it, is run yarn start. And then, as I said before, it will start the different microservices. It will set up a HTTPS tunnel using local tunnel. And then you can use any of these endpoints to either create a GraphQL schema with StepSend, for which the files are in this repository, or you can start building anything with Apollo server, or Mercurius is a good example, but there are also ways to set it up with Express. I did ever find out that Express isn't that performant with GraphQL, so it's something to think about, and then Mercurius could be a nice setup. Make sure to use this config YAML file to input the local tunnel addresses there, and then you should be able to run StepSend start as well to create a GraphQL schema for you. So this was mostly what I want to talk to you today. So thanks again for listening. Also thanks for the warm welcome here in the Canarias. I think it's really good to be back. And I really like these community conferences instead of larger communities. And something one of the organizers said to me yesterday, it must have been great for you as well to actually have people coming to your islands to speak instead of you having to fly all over Spain or different parts of Europe to listen to talks. So I hope you enjoyed it, and I also hope to see you later today. So thank you.
Hola. Questions? Someone? Any question?
So, thanks, Roy. So I wanted to ask, what do we gain by merging schemas together? Like, why is that necessary, first of all? Do we need to merge schemas together first? And second, what do we gain by doing it?
Yeah, so the question if you need to merge schemas together is a good question. I think it's also a question that very much depends on your situation. So yesterday I was talking with someone on Twitter saying you maybe don't need React or you maybe don't need to use this API. I think my answer was I also don't need to wear pants when I'm at home. Luckily I'm wearing pants now. But you don't really need to merge schemas together. But if you're using microservices and you want to combine data, then typically it's something you don't want to do on your front end. It could be fine if you have just one front end, but if you have microservices for one front end, I would wonder why you actually have microservices. So typically your microservices will feed multiple front ends or multiple, maybe even micro front ends or completely different applications. And all these applications will use your data differently. So by making it possible to merge data with your schemas, these applications can remain stupid, so they don't need to know about how the data correlates. Instead, they will just send a query, or they will just call one REST API endpoint from your REST API gateway. So you don't want this logic to be implemented in your front end. And what do you gain with this? It's more extensible. You keep your front end stupid, which is something I always like. And performance-wise, it can also be nice to implement caching. So if you send a request to get your data in one application, then maybe you could cache it for the other application. Or maybe if you reuse that same endpoint later on, it will be cached, so it will give you some performance gains. But it's a good question, and it really depends. If you have a small company, then probably don't do microservices and don't do an API gateway. Just create GraphQL for your monolith, and then you should be able to use most of these things as well. But you don't need to merge the schemas, you just create one schema.
Thanks, Roy.
Thank you. No more questions? Okay. Thank you so much, Roy.
Thank you.